As a Filipino growing up, how many times have you heard of the phrase, noong panahon nga namin, from your parents or grandparents? Now, this particular phrase is actually significant in learning the fundamentals of economic growth. Now imagine having a 1,000 peso bill during the late 1950s. I bet we can fill up a cart full of groceries with that. Pero mukhang hindi na natin ma-experience yan this time.
I believe tama ka dyan, Trisha. I actually saw a Facebook post last time and it shows kung saan naabot ang 1K na yun. And I feel disappointed kasi hindi kaya mapuno isang grocery cart with 1,000 pesos unlike before. I guess our 1,000 pesos doesn't feel like 1,000 pesos.
I think that serves as a reminder to us that inflation is right here in front of us. Not only that, our standards of living are moving forward. Pero sana pati income natin move forward. Kidding aside, it is evident that standards of living progress as time passes by. In addition to that there are rising levels of income. With this, we can say that standards of living plus rising income equal greater consumption.
But the question is, how do we even measure economic growth? According to Mankio, economists use GDP data, which measures the total income of everyone in the economy. In this case, we would like to determine how income changes over time. When it comes to economic growth, there are three things that we have to consider first, and these are capital, labor, and technology.
Come on and take journey as we learn more about economic growth in an economy. But before everything else, I want you to meet Robert Solow. He's an American economist who is also known for his important contributions in the field of economic growth. During the 1950s, he also developed a mathematical model that illustrates factors that contribute to economic growth, which led him to win the Economic Science Prize. Here, you can also meet Solow model. Solow model is a growth model that is designed to show the theoretical economical effect on GDP, as well as the interaction between capital stock, growth in labor force, and technological advances. Aren't you curious on how our savings, population growth, and technology affect our economy's output or growth in general? Just keep on watching.
Wait! Before all of us meet Solow model, it is important for us to take into consideration the supply and demand for goods. Yes, you heard it right. We have to go back and learn the basics once more in order for us to determine how capital is accumulated in an economy. Supply and demand has always been playing an important role in economics. Going back, let us recall that the production and allocation of output is determined by the supply and demand for goods.
Hey guys, this is going to be a little bit mathematical, but I hope you remain focused in our discussion, since this part is going to be exciting and interesting. For the Solow model, the supply of goods is based on the production function, which states the output depends on the capital stock and the labor force. This just means that the production function shows how much output Y the economy can produce from K units of capital and L units of labor.
Now, let's take a look at this graph to give us a clearer picture of how production function works in the accumulation of capital. Let us recall that the production function displays the amount of capital per worker K and how it decides the amount of output per worker, which is Y is equal to F times K. In this case, the slope of the production function shows how much extra output a worker produces whenever given an extra unit of capital. This is what we now refer to as the marginal product of capital, or MPK, wherein MPK is equal to F times K plus 1 minus F times K.
With all this being said, we can conclude that when capital increases, the product function becomes flatter. To make it simpler, when capital is low, the workers will only have a little capital to work with, which makes an extra unit of capital produce a lot of output. In contrast, when capital is high, the workers will have a lot of capital to work with, which makes an extra unit of capital produce a slight output.
We finally learned the supply of goods and its relationship with the production function to the accumulation of capital. In this part, we are now going to take a deeper look into the demand of goods and the consumption function. Solow model wants us to realize that the output per worker is divided between the consumption per worker and the investment per worker. The formula is written as Y is equal to C plus I.
You might notice in the equation that there is no government purchases and net exports involved. Why do you think so? It is because we are assuming a closed economy and we can ignore present purposes. Thus, we aren't the one who can only assume. Solow model assumes that each year people save a fraction of their income and consume a fraction of it as well. In this case, we are given the equation of a consumption function. But when it comes to investment, we substitute the quantity of 1 minus S times Y for C, wherein Y is equals to the quantity of 1 minus S times Y plus I.
When we rearrange the terms given, it will give us the equation I is equal to SY. In short, investment is equal to saving. The rate of saving S is also the fraction of output devoted to investment. This gives us now the idea that supply and demand, as well as production function and consumption function, play an important role in describing the economy at any moment in time.
Interesting, isn't it? This makes Solow model something that we want to get to know better. Let us keep in mind that for any given capital stock, the production function determines the output, while the saving rate determines the allocation between consumption and investment.
Just like our parents' time and season, capital stock also changes over time, and it serves as an essential role in determining the economy's output. Noong panahon kaya nila, what do you think is the amount of capital stock? Nevertheless, changes in capital stock leads to economic growth, just like changes in our parents' time and season, which leads to growth in life.
There are two things that we need to take note when it comes to capital stack. These are the investment and depreciation. Investment is also known as our expenditure in plant and equipment. On the other hand, depreciation is the wearing out of old capital. Thus, we can conclude that the capital stack increases in investment while capital stack decreases in depreciation.
Here's another graph for us to understand the relationship between output, consumption, and investment. As we have tackled earlier, I is equal to SY, where investment is equal to saving. If we substitute the production function for Y, we will have an equation that displays the investment per worker as a function of the capital stock of worker. This means that for any level of capital K, the output is FK, the investment is SFK, and the consumption is Fk minus Sk. It also gives us again the notion that the saving rate determines the allocation of output between consumption and investment.
And to incorporate depreciation into this, we can express the impact of investment and depreciation on the capital stock using this formula. Change in capital stock is equal to investment minus depreciation.
To show the terms mentioned by Eliza in a graph, here is another model. This indicates that the higher the capital stock, the higher the amount of output and investments. Also, the higher the capital stock, the greater amount of depreciation too. Take a look at how the steady state of capital K star is the level at which investment equals to depreciation, showing that the amount of capital will not change eventually. When capital per worker is below its steady state, investment exceeds depreciation, making the capital stock grow. When it is above K star, depreciation is more than investment, making the capital stock shrink. Over time, the capital stock will rise with output F of K until it approaches the steady state K star.
That's too long. Basta guys, kapag nasa K2 ang level ng capital, mas mabilis itong mauubos kaysa mapalitan dahil mas konti ang investment kumpara sa depreciation. E di bababa uli yung capital stock sa K para maging steady ito. Kapag nasa steady state na siya, okay na kasi equal na rin yung investment sa depreciation.
To further explain how the economy approaches the steady state, we can use numerical examples. This is the Cobb-Douglas production function. Y is equal to K raised to the power of 1/2 times L raised to the power of 1/2. From this, we can derive the per worker production function by dividing both sides by labor force. Y over L is equal to K raised to the power of 1/2 times L raised to the power of 1/2 all over L. We then rearrange the equation. Y over L is equal to the quantity of K over L raised to the power of 1/2. Because Y is equal to Y over L and K is equal to K over L, it becomes Y is equal to K raised to the power of 1/2, or Y is equal to the square root of K. This form of production function states that the output per worker equals the square root of the amount of capital per worker.
With that, we can now proceed with this table. This presents how new capital is added, and output grows yearly because investment exceeds depreciation. This leads to the economy to approach a steady state, with 9 units of capital per worker through the years.
That's right, Kevin. Hey! Another way to follow the economy's progress is using equations such as this one. We recall that change in capital stock is equal to investment minus depreciation. By definition, we determine that change in capital stock is equal to 0 in a steady state. This equation provides a way of finding the steady state level of capital per worker K asterisk.
Now, using the same example in the table and our production function, we should get this mathematical model. After squaring both sides, we obtain this. This should confirm the data presented in our table, where, as mentioned earlier, the steady-state capital stock is 9 units per worker.
Moving on, we shall discuss the success of Japanese and German economic growth. Let's note that in 1945, the economies of Japan and Germany were in a disarray. However, between 1948 and 1972, both countries miraculously grew economically. Ang galing, di ba? During these years, output per person grew at 8.2% per year in Japan and 5.7% per year in Germany, both relatively higher compared to only 2.2% per year in the United States. How do you guys think this happened?
Well, if we look at it, using the Solow growth model, it is not surprising at all. We assume that the economy from a steady state post-war experienced a drop in the capital stocks during the war. Despite their outputs falling, the economy can still grow highly as their saving rate remains unchanged. By the way, the saving rate is the fraction output devoted to saving and investment.
Yes, that's right. Hey! And during our discussion, we identified that output grows at the lower capital stock because more capital is added by investment than is removed by depreciation. This high growth continues until the economy approaches its steady state.
Now, in addition to that, Japan and Germany save and invest a higher fraction of their output than does the United States. Now, using this graph here, we can see that an increase in saving rate implies that the amount of investments per capital stock is higher. Now, at the former steady state, investment exceeds depreciation. The capital stock then rises until the economy reaches a new steady state with more capital and output.
The saving rate is an important factor of steady state of the capital stock. As shown by the Solow model, high saving rate means the economy will have a large capital stock and a high level of output in the steady state. while low saving rate means the economy will have a small capital stock and less output in the steady state.
We can now understand why a lot of economies see continued budget deficits unfavorably. Budget deficit can reduce national savings and investment, and with a reduced saving rate, a country will have lower capital stock and lower national income.
Well, that makes me wish we had more economists in the Philippine government.
Anyway, here's another figure to help us visualize the large scale of different standards of living internationally. Now, this scatter plot shows the variation of about 100 countries. Now, the horizontal axis shows a nation's rate of investment, and the vertical axis shows the income per person. Now, in accordance with the prediction of the Solow model, high investment is linked with high income per person.
Disclaimer alert! As a disclaimer, we acknowledge that the association between investment rates and income per person is not absolute. There can be other factors of living standards other than saving and investment. We shall learn further about international differences as we continue to explore different topics in macroeconomics.
And that concludes our discussion for today's video. See you on the next episode of Economics!
You can still like, share, and subscribe.
Wait! Let's take a short break muna. Ask ko lang if you guys have a golden rule in your life. Like for example, yung you do unto others as you would have them do unto you. Now I bet all of us want people to treat us with respect. Kaya naman we should also treat them with respect too, right?
Yeah, that's real, I agree with you, Trisha. This will serve as a guide nga naman for us to choose for others what we would choose for ourselves. Pero what's the point nga naman for all of these? What's with the golden rule? May kinalaman ba ito sa economics?
Hey! Cut off ko muna kayo dyan, ha? Let's pause the chismis. But you're actually right, Eliza. When it comes to capital accumulation, there is what we refer to as the golden rule of capital. To make it short, this is what we call consumption maximizing. Teka, magbibigay ako ng senaryo para mas lalo nating maintindihan ang rule na ito.
Ay, wag ganun. Ano yung kailang may spotlight? Kidding aside, I think it is best if I, Bian, will explain the scenario. For instance, si Kevin ang policy maker na may kakayahang mag-set ng saving rate at any level sa ating ekonomiya. With this, we can conclude that Kevin can also determine the economy's steady state since they set the saving rate. Pero ang real question dito, anong klaseng steady state ba ang dapat piliin ni Kevin? Ang goal niya kasi dito is to make sure that they can maximize the well-being of the individuals who make up the society. Let's say na kayo, Trisha and Eliza, ay walang pake sa nangyayari sa ekonomiya ng bansa. Hindi nyo kailangan bigyang pansin if anong amount na ba ang capital at output natin. All you guys care about is the goods and services that you will both consume. This is why we need Kevin dahil siya ang magsisilbing hero nating lahat since he can choose a steady state with the highest level of consumption.
Naku, ang dami mo nang sinabi. Let's keep this short. It just means that I, as the policymaker, have the ability to choose what kind of steady state. With this, I can choose the golden rule of capital in order for everyone to maximize consumption and happiness.
Thank you so much for that, Kevin. Grabe, we really appreciate your kindness and consideration. Kidding and cheese aside, the golden rule of capital is a steady-state value of K that maximizes consumption and is denoted by K asterisk gold.
That's great, guys! Hey! Now, all of us are aware what the golden rule of capital is, but of course, there are still a lot of questions that we have in mind. Like, paano nga ba natin masasabi if an economy is at the golden rule level? The first thing that we have to do is to determine the steady-state consumption per worker.
The formula is written as y is equal to c plus I, then we rearrange the formula to get c is equal to y minus I, or consumption equals output minus investment. Of course, hindi pa tayo tapos and papunta pa lang tayo sa exciting part. Take it away now, Kevin.
Thanks, Eliza. The next thing we have to do now is to find the steady-state consumption. And to do that, we have to substitute steady-state values for output and investment. This will give us the formula C star is equals to F multiplied to K star minus K star. Let us keep in mind that this equation displays that an increase in steady-state capital has two opposing effects on steady-state consumption. Thus, capital increase and income also increase.
That is why when it comes to comparing steady states, it is important for us to take note that higher levels of capital affect both output and depreciation. If there is an instance wherein the capital stock is below the golden rule level, there will be an increase in the capital stock as it raises output more than depreciation that raises consumption levels.
As we all know by now, steady-state consumption is the gap between the output and depreciation. Now, we can conclude that if consumption increases, then K also increases. On the other hand, if capital stock increases, then the consumption decreases. Thus, the golden rule is described by this equation to make the marginal product of capital equals the depreciation rate.
Now that we are moving on to our next topic, we shall expand the Solow model to add another factor of economic growth, namely population growth. After we regarded the population as something fixed in the previous sections, we now suppose that the population and labor force grow at a constant rate n. For example, if the US population grows about 1% per year, then n is equals to 0.01. If 150 million people are working this year, and then 151.5 million are working the next year, and 153.015 million the year after that, we get the next value by just multiplying 0.01 to the initial number and then adding.
To finally correlate the population growth with steady state, we must first explain the effect of population growth, investment, and depreciation to the accumulation of capital per worker. Since there is now a third factor, we shall use this mathematical model to represent the change capital stock per worker. Take note, we have already determined that investment raises the capital stock and depreciation reduces it. In addition to that, the growth in the number of workers causes capital per worker to decrease.
In this equation, it can represent a break-even investment. It is the amount of investment necessary to keep the capital stock per worker constant. It includes the depreciation of existing capital and the amount of investment necessary for this purpose is NK. As Malthusian states, this equation shows that population growth reduces the accumulation of capital per worker much the way depreciation does. Depreciation reduces K by wearing out the capital stock, whereas population growth reduces K by spreading the capital stock more thinly among a larger population of workers.
We see the determinants of the steady-state level of capital per worker. Depreciation and the population growth are two reasons the capital stock per worker decreases. If N is the rate of population growth, then K is the rate of depreciation. Then, positive N is to K is break-even investment. For the economy to be in a steady state, investment SF is to K must offset the effects of depreciation, and population growth positive N is to K. This is represented by crossing of two curves.
To now discuss the effects of population growth, we shall note that it makes a difference in the basic Solow model in three ways. First is that it helps us in explaining sustained economic growth. Although population growth cannot explain sustained growth in the standard of living, it can help explain sustained growth in total output. The second effect will be accompanied by a graph, so I am passing the mic to Dion.
Wow, great. Okay, so the second one is that population growth provides another reason why other countries are rich and others are poor. Let's take a look at this graph for visualization.
An increase in the rate of population growth from N1 to N2 shifts the line represents population growth and depreciation upward. The new steady state K2 asterisk has a lower level of capital per worker than the initial steady state K1 asterisk. Thus, the Solow model predicts that economies with higher rates of population growth will have lower levels of capital per worker and therefore lower incomes.
You're literally the best, Dion. And lastly, population growth also affects our basis for determining the golden rule level of capital. To prove this, we can use a mathematical model. Note that consumption per worker is C is equal to Y minus I. And we can express steady-state consumption as the equation given in the screen. We conclude that the level of K asterisk that maximizes consumption is the one at which, in the golden rule steady state, the marginal product of capital net of depreciation is equal to the rate of population.
Now, we shall return to this question. Why do standards of living vary so much around the world? Bakit nga ba may pagkakaiba? The answer can be one of the answers, as the Solow model suggests that a nation with a high rate of population growth will have a low steady-state capital stock per worker, and thus also a low level of income per worker. This means that high population growth makes a country poor, due to the fact that it is harder to maintain a high level of capital per worker when the number of workers grow rapidly.
We have another scatter plot here to help you visualize the international evidence on population growth and income per person. This figure shows data from 100 countries in which we can see that countries with high rates of population growth usually have low levels of income per person. Countries like Burundi and Zimbabwe prove the claim of the Solow model.
However, we must keep in mind that we are interpreting cross-country data. We are using this figure to further explain the points of the Solow model. But other explanations that cause these numbers may also be possible. It is also plausible that it's the other way around. High income encourages low population growth, perhaps because birth control techniques are more readily available in richer countries. The data presented can evaluate the theories, but remember, that correlation does not imply causation all the time.
We are now introducing another model to grasp the concept of population growth. Unlike the Solow model that features the interaction between population growth and capital accumulation, this model shows that high population growth decreases output per worker, because when there is a quick growth in the number of workers, capital stock tends to spread thinly, which results in each worker being equipped with less capital in the steady state.
In his book, An Essay on the Principle of Population as it Affects the Future Improvement of Society, the early economist Thomas Robert Malthus introduced the Malthusian model. Malthus predicted that mankind would forever live in poverty as its continuously increasing population would affect society's ability to provide for itself. Now, Malthus also argued that attempts by charities and governments to reduce poverty were counterproductive. These attempts, as described by Malthus, only allowed the poor to have more children, putting the society at a higher risk of greater poverty.
Grabe naman. With all due respect to Sir Thomas Robert Malthus, don't you guys think that only puts the burden on those who are victims of the system? We all know that sex education and birth control methods aren't accessible to all. What more to those struggling, diba?
Well, he may have described the world solely based on the conditions during the time he lived. Even his claim that mankind would remain in poverty forever is proven to be false at the present time. The world population has increased big time, yet average living standards are much higher today.
In addition to that, Malthus failed to predict that the society's innovativeness would offset the negative effects of a large population. Today, mankind has invented pesticides, fertilizers, mechanized farm equipment, new crop varieties that help the production of food, a necessity in our daily lives and something that generates income.
I agree. To evaluate our discussion, we can also talk about the Cramerian model. In contrast to Malthusian model, this model by Michael Kramer suggested that population growth is the key driver of an advancing economic prosperity. For Kramer, more people means that there is more scientists, more investors, and more engineers to contribute to technological progress.
It is very interesting that these models are the complete opposite. Kramer supported his claim by noting that over the broad span of human history, world growth rates have increased together with world population. The world growth was more rapid when the world population was 1 billion around 1800s than it was when the population was only 100 million around 500 BC.
Another evidence provided by Kramer was a comparison of different regions of the world. Technological progress is more rapid when there are more people to discover things. So, the more populous regions experience more rapid growth. The most successful region of the world in 1500 included the Old World civilization of the large Eurasia-Africa region. On the other hand, the least populous region, Flinders Island, had the least technological advancement. It, in fact, seemed to regress as around 3000 BC. The human society there completely died out. Kramer concludes from these evidences that a large population is a prerequisite for technological advance.
Now, to summarize our last in today's episode, first, we learned that the Solow growth model shows that in the long run, an economist's rate of saving determines the size of its capital stock and thus its level of production. The higher the rate of saving, the higher the stock of capital, and the higher the level of output.
Second, in the Solow model, an increase in the rate of saving has a level effect on income per person. It causes a period of rapid growth, but eventually that growth slows down as the new steady state reach. Thus, although a high saving rate yields a high steady state level of output, saving by itself cannot generate persistent economic growth.
Third, the level of a capital that maximizes steady-state consumption is called Golden Rule level. If an economy has more capital than in Golden Rule steady state, then reducing savings will increase consumption at all points in time. By contrast, if the economy have less capital than in Golden Rule steady state, then reducing the Golden Rule requires increased investment and has lower consumption for current generation.
And lastly, the Solow model shows that an economy's rate of population growth is another long-run determinant of the standard of living. According to the Solow model, the higher the rate of population growth, the lower the steady-state levels of capital per worker and output per worker. Other theories highlight other effects of population growth. Malthus suggested that population growth will strain the natural resources necessary to produce food. Kramer suggested that a large population may promote technological progress.
Whew, now that's a lot. I hope you guys learned from our episodes. Sadly, we have to say goodbye for now.
Ang drama naman. But thank you for taking time to study this chapter with us, everyone.
And that concludes our discussion for today's video. See you on the next episode of Economics!
You can still like, share, and subscribe.